In this video lecture, we're going to write a simple program to print out prime numbers. Okay, so we've learned about loop systems, and we've learned about for loop, while loop, and do while loop. Let's go ahead and create a simple program that is going to print out prime numbers using one of these loop systems, and I'm going to use a for loop. And in this case, I will use this to teach you about nested for loop in C programming language. So let's go ahead and initialize some variables, and I'm going to initialize these variables called int x and y. So put a semicolon at the end. So using a for loop, I'm going to say for x, and this is going to start from 2, put a semicolon there, and let x be less than 50. So we're going to take a prime numbers from 2 to 50, and here x is going to increment because it's going to be continuous process until it gets to 50. So now go ahead and put a curly brace, and then go ahead and put another for loop. So in this case, you're trying to create what is called a nested for loop. So when you say something is being nested, it means that you're putting something into another. Imagine a bed creating a nest, twisting things together, and in that way, you can be able to create a for loop that is inside another for loop. So whenever you have a for loop inside another for loop, it's called nested for loop. And this is applicable to while loop and do while loop. So you have nested do while loop and nested while loop. So they are just similar. So in this case, we are using the very first for loop to check or to give a condition that you are going to start this process from 2 and ends at 50. And then the next one, that is the second for loop now, is going to be able to create a function that will help us to check the prime numbers. So once you create for, you go ahead and say y equal to 2, put a semicolon, and y less than or equal to, put a parenthesis there, x divided by y. So x divided by y, that it means is the value of x divided by the value of y. And y increment, so keep doing this from 2 to 50. Now you have to give a condition, and you're going to say if, so if x, or if not x. Alright, so if not x divided by y. So what this means is going to, if x cannot be divided by y, is going to break out. Okay? So it is not a prime number. So let's go ahead and call break. Wow, that is break. And put a semicolon at the end. So in another way, you can be able to write this, because I know as a beginner you might see this, like, what am I doing? So you can put a curly brace right here. I'm trying to show you some different things you can do. So put a curly brace here, and go ahead and put if statement. So if not, we're trying to check which is prime number and not. So x divide by y. Okay? Then you break out. So put a semicolon at the end. And now outside this, you go ahead and say if if y is greater than x, divide, wow, that is division, divide by y. Wow. If x divide by y, so go ahead and close this if statement, then you go there and print out. Let's go ahead and print out this, and I want to say %d is a prime number. So I'm going to explain this right now. So let us go back to the next line and then put a value, put a comma here, and put a value of x right here. So put a semicolon at the end. So what the system does now is, for the very first one, the very first for loop here, we use that to give a condition that this process is from 2 and it ends at 50. Now it's going to print out prime numbers from 2 to 50 and use the second number to check if the numbers divisible by 2. Is that divisible by 2? If not, then it's not a prime number. But if it is divisible by 2, it's not a prime number. And if it's divisible by 2, I don't know if I'm making a mistake by divisible and non-divisible, because I'm trying to explain this. So numbers that are not divisible by 2. Okay? Or numbers that are divisible by 2. That's why I put not right here. So let me check, put that stuff, and let me put a comment right here. Numbers that are divisible by 2 and not prime numbers. Okay? And numbers that can only be divided by themselves are prime numbers. I think that is what prime number is all about. So numbers that are divisible only by themselves are prime numbers. So we use these to check numbers that are divisible only by themselves. And if they are not divisible by themselves, then they are not prime numbers. But if they are divisible by themselves, then the second if statement, we're going to hold that and it will print out those numbers for us. So if you've got this, let's go ahead and run this code and check that out. So numbers that are only divisible by themselves will be printed out here and they are prime numbers. So run this code and let's check this out. Hope the code is good and there is no error anywhere. So now we see that right here, and that says this is a prime number. Wow. Oh, this cannot be a prime number. Let's cruise this. Let's check this out. So we are getting everything printed out. So what we need to put here is percentage. This percentage should be modulus and not division. So change this to modulus. Okay? Change this to modulus and not division sign so that you can be able to get only the numbers that are divisible by themselves. So go ahead and run this code again and check it out. Let's check that out. Alright, so that is here. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. I hope you can see that. Go ahead and close this, or I can bring it down so that you can be able to look at the code. I hope that is not blocking this. I'll keep that right here. I hope that can be visible. So now we checked for the very first condition here, we check numbers that are not divisible by themselves. So if they are not divisible by themselves, or if they are only divisible by themselves, then they are prime numbers. So the second condition will help us to print them out. But when you check the first condition, if they are divisible by y, therefore they are non-prime numbers. Okay? So you asked me, what is the use of modulus? Modulus is used to check the remainder. So if there's no remainder, alright, so if there's no remainder, that means they are not prime numbers. But if there's a remainder, then they are prime numbers. Okay, that is why we have not right here. So remember I taught you on how to use modulus when we did operators, arithmetic operators. So if you want to get the remainder, you use the modulus. So if there is no remainder at this point, that means it's not a prime number, because a prime number must have a remainder. So whenever you divide 7 by 2, you're going to get 3.1. So that is a prime number. Okay? So this is all about using nested for loop to print out prime numbers in C programming language. Go ahead and pull it down and check it out. In case you get confused or anywhere, please use the question and answer section, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture.